Okay, good morning, guys. It is Tuesday, and just want to go over the week agenda here, cover the two starters, and discuss what's going on. Had a little bit of internet shortage with that storm yesterday, so let's look at the bell ringer from yesterday and today, and then I'll make a separate video in terms of expectations for the week. So first, let's look at the starter. It asks, which way does blue light change as it travels from diamond into crown glass? So anytime we're talking about light, we want to make sure we talk about the indices of refraction. So remember, the indices of refraction are found in your reference table, and that can be noted on this slide. I wasn't able to get a great picture, but here's your indices. Remember, air is the speed of light, and as we get more dense, like into diamond, we see that light slow down. So as it travels from diamond into crown glass, it's actually going into a less optically dense. It's going from 2.42 to about 1.5. So it should increase its speed. Remember, frequency is source dependent, so that would be the sun in this case. It's actually emitting the electromagnetic spectrum. Frequency isn't going to change. Speed would. And it's going to decrease if it goes into a more dense, but it's going into a less dense. It's getting closer to the refractive index of 1. So we would see the speed increase. Number 2, monochromatic light ray means it's a single color. Polychromatic would be white light. It's traveling from air into lucite, and lucite is more dense, so we should right off the bat say it's going to bend closer to the normal. If the angle of incidence is 45 degrees, what's the angle of reflection? Well, first thing we want to do is let's remember that angles are measured from the normal. So this is your 45 degrees. It's really hard to draw this on the trackpad. I apologize. 45 degrees. And we're looking for some line that is going to be closer to the normal. Right here. And again, it's more dense, so we would expect it to be closer. Plug everything in, you have incident angle of 45 degrees, refractive index of 1, and then for the refractive index of the other is 1.5, and we're looking for theta. According to Snell's law, you should get something about 28 degrees here, and that's what you would put right in. Whoa, all the way over here. And then lastly, this is really kind of an interesting one. What's the angle of refraction of the light as it emerges from lucite back into the air? So let's imagine that this ray continues and it reaches this boundary here. We would need to create another normal, which I will attempt to do here. There we go. There's a new normal. And we're looking for this next angle. So now we're going from a more dense medium here to a less dense, and it would bend away. And the interesting thing is, if you plug everything in, you actually notice that this angle is the same angle that it entered, so 45 degrees. Good morning, James. You ready to come hang out with me? Okay. Thank you. James brought me his big 3-foot dinosaur you can't see. Maybe I'll take a picture and send it to you guys. And Chickaletta from Paw Patrol. James, you want to say hi? And he's going to get a very large stuffed fish. It is a largemouth bass. So I am teaching now with a 4-foot dinosaur, a Paw Patrol Chickaletta, and a bass. I will take a picture and send it to you guys. Let's look at the Tuesday starter here. This is all EM spectrum. Compared to the speed of a sound wave in the air, the speed of the radio wave is, you know what I'm actually going to do? I'm going to pause and take a picture now because I have a feeling that he is going to take these away, and you guys really should see this. So stay tuned. I'll get you the next bell ringer here in a minute.